How's everyone doing? You're back with Jono for another quick math lesson. Today we're going to look at trigonometry, really the fundamentals of this topic. The thing that I have found with my students over the years of teaching this topic is that students assume this is going to be incredibly hard. But I guarantee you, trig is one of the easiest topics we do in maths, especially at the start. The mathematics behind all the things we're going to look at is incredibly simple to do, especially on your calculator. So all I need from you, if you're watching this, is have a positive mindset, because I guarantee you'll find it pretty easy. So as you might be able to see in the name, trigonometry, we are talking about the properties or the geometry of triangles. And to start off, we're only going to look at right angled triangles. This is really good because we've done Pythagoras before, so we already have a little bit of understanding of how these triangles work. The best thing about trig is you only need to know 6 words in order to smash out the entire topic. They are new words, they're a little bit hard to kind of wrap your head around, but once you've got these 6 down, you cannot go wrong. So the first thing you've got to be able to do is when you have a triangle, if you can label the 3 sides with 3 of these new words, you are more than halfway to getting every single question right. The thing that we always have to look for is the angle of interest. So every single question you get is going to have a triangle with a right angle and one of the angles filled in with a sign delta. This angle, delta, defines what the sides are going to be. And we're going to see that in an example now, but just make sure you are always looking for the information that's been given. So the right angle and the angle of interest. So as we can see in this example, we've got the angle of interest down in that bottom corner. And then we have to label the sides based on this position. From Pythagoras, we already know that the longest side is called the hypotenuse, which is also always opposite the right angle. But we're going to throw that in straight away. That label of hypotenuse goes on that long line immediately. We have 2 other sides. Just like I said then, the hypotenuse is always opposite the right angle. We actually call the other side of our angle of interest the opposite of as well. So all the way over on this side here is our opposite side. And we just have to label that O. Finally, there is one angle that is attached that's not the hypotenuse. This is actually called adjacent to the angle, but I always think about it as attached. So this side that is next to our angle of interest, that's not the hypotenuse, is our adjacent angle. So just make sure you've got those 3 words down. H stands for hypotenuse, or the longest side. O stands for opposite, which is on the other side. It's as far away as possible from our angle of interest. And A stands for adjacent, or the thing that is attached to the angle that's not the hypotenuse. If you've got those 3 words down, you're halfway to mastering trig. So sometimes you're going to be given a triangle that has 2 angles of interest at the same time. The reason that this is important is because the O and the A can change depending on where the angle of interest is. The hypotenuse always stays the same, it's always the longest side, but the other 2 depend on which angle is in which corner. So we're just going to have a look at this angle first. We know that H is going to be the same, which is equal to 5. O for this angle is all the way on the other side over here, so that has to be 3. And then attached to that number is the 4, or the adjacent is the side length 4. So for that first angle, we have the hypotenuse is 5, the opposite is 3, and the adjacent is 4. But if we then look at the other angle of interest, if we decide that angle is more important, these numbers slightly change around. So now if I have a look at this angle of interest, the hypotenuse remains the same. It's the longest side, so it's equal to 5. But opposite this angle, all the way on the other side, is not the 3, like in the last one, but the 4. And then the attached angle is the side length of 3. So I know that that is seemingly pretty annoying, but it just shows that it is relative to the angle. The angle of interest is incredibly important to find first, and then everything else will fall into place. So why is this important? We can use these 3 side lengths in order to work out every single question using 3 trig ratios. So I said we'd learn 6 words and master trig. We're halfway there. The next bit is where the maths kind of comes into it. We're just going to go through the trig ratios incredibly quickly. There are some really good visual explanations of how these exactly work together on YouTube, and I've linked them in the description below. For our purposes, what we need to know is that the angle of interest and the opposite side are incredibly linked. So in this triangle here, we've got a small angle. This x is not that big, and that means that the side length opposite it, the big X there, isn't that big either. But we can see if I start to open that X up or increase the size of that angle, that's going to force that opposite side to increase. And then finally, if I open it up as far as I can, that big X on the other side gets incredibly big quickly. You actually can't complete the triangle without these two things being related. So all we need to know is that there is obviously a relationship between the size of the angle and the size of some of the side lengths. In those ones, the adjacent side or the bottom side didn't change, but the opposite and the hypotenuse changed as a result of the angle changing. So trig ratios just tell us how these things interact together. So the three relationships that are important are sine, cosine, and tangent. So the sine of an angle is equal to the length of the opposite side divided by the hypotenuse. As we saw in those examples, as the opposite side got bigger, the hypotenuse got bigger as well, and we can just work out how much they change using this sine of the angle. The next one is cosine. In that example, the adjacent side did not change, but the hypotenuse did. The cosine actually means the complementary of sine, so it's kind of the opposite. And then tan ignores the hypotenuse and just looks at how the opposite side reacts to the adjacent side. So these are just a whole bunch of words that are popping in, and I guarantee you we're going to use them, and it's not going to be too difficult. The way that we remember which ratio goes with which sides is incredibly easy. It is SOHCAHTOA, and you'll hear it all the time throughout this topic. The way that I want you to write it down is this bottom one, where we've got SOHCAHTOA, but the O and H are written on top of each other. This is just because this is what it's going to look like in the fraction, and it'll hopefully just minimize any potential mistake. So all we've got to do to be good at trig is label the sides and then remember if it's sine, cosine, or tangent. So for this example here, my angle of interest is in that bottom corner, and the two sides that I've been given, the 4 and the 6, are the opposite side, all the way over there, and the hypotenuse, or the long side. So if I've got O and H from SOHCAHTOA, I know that sine is the correct trig ratio for these two sides. The mathematical sentence that we write from here is that the sine of this angle is equal to opposite, or 4 over 6. That's all we've got to do for this lesson. If you can label the sides and then relate that to our SOHCAHTOA, you're going to be fine. In this example here, the angle of interest has changed, so that means that the two sides I have changed as well. I still have the hypotenuse, but this time the 8 is the adjacent. This means that instead of sine, I have cosine. So cosine of this angle theta is equal to adjacent over hypotenuse, or 8 over 12. Please keep referring back to that SOHCAHTOA. I have it on every page when I do trig, just to make sure that I don't forget. Last example here, the angle of interest is down in that corner, but the triangle has been moved around. This time I don't have the hypotenuse. I've got the opposite over here and the adjacent standing next to it. That means that I've got tan of that angle is equal to, TOA is O over A, so I have 9 over 7, and that is full marks. I hope you guys found this helpful. Please stick with trig. I guarantee it gets easier from here. These 6 words define everything that happens with trig. So if you're on top of that, you're going to find the next couple of weeks incredibly easy. Thanks so much, guys, and I'll see you later.